Alright, today we are going to talk about solving rational inequalities. So we just learned how to solve rational equations, and so now we're going to do rational inequalities. Now, when we were solving rational equations, the technique that I used, I just multiplied everything by basically the denominators and just canceled it all. Now, I don't want to do that with a rational inequality, and that is because anything that would make the denominator 0 here would actually possibly cause my graph to change signs. So what I want to do in these cases, it's very much like a quadratic inequality. Basically, I move everything to one side of my equation so that I have 0 on one side, but in the extra step of a rational inequality is I need one single fraction. So that means I'm going to need to move this 3 to this side. So I'm going to have 2x minus 7 over x minus 5 is, or minus 3, is less than or equal to 0. All right, so now what I want to do is get a common denominator. Well, the only denominator that I actually have is x minus 5. So this is the denominator that I want. So this piece already has the denominator that I want. So my next step is to make a common denominator. Now I want to think of 3 as 3 over 1. So I need it to have this x minus 5 in the bottom. So of course I multiply both the top and the bottom because I want it, it's like I'm multiplying by 1. And this is less than or equal to 0. So now I'm going to write 1. I want to, my end game here is to make one fraction on the left. All right, so I have 2x minus 7 over x minus 5, and then minus 3x minus 15 over x minus 5 is less than or equal to 0. All right, my last step then is now they have the same denominator and I've got them all cleaned up, is I can put them over one fraction. So I have x minus 5, I have 2x minus 7. Be really careful, this minus sign applies on both of these things, so I get minus 3x minus 15 is less than or equal to 0. All right. So a little bit more algebra. I get 2x minus 7 minus 3x plus 15 all over x minus 5 is less than or equal to 0. All right, last step, I can combine some stuff up here. I get negative x because I have these two common things, and then I have negative 7 plus 15, which is plus 8 over x minus 5 is less than or equal to 0. All right, so now that I've achieved my end goal here, I've got it into one single fraction. Now this is kind of like the quadratic part, is basically I find any 0 that would make my numerator 0 because that would make my overall function 0, and I find any number down here that wouldn't be part of the domain. So from the top, right, I set them equal separately really in my mind. I have negative x plus 8 equals 0, so that's going to give me 8 equals x, and x minus 5 is equal to 0 gives me x equals 5. These are the two places that either my function is 0, right, if I plug in 8 up here, I'm going to get negative 8 plus 0, which gives me 0, or undefined. Now I care about the zeros, right, just like I did with the quadratics, because my function can't go from positive to negative without crossing 0. So that's why I care about the numerator. Why I care about the denominator is, we haven't talked in detail about this yet, but maybe you've seen some of the graphs, is my graph does a weird jump over the top of this because this is a place where my function is undefined, so my graph doesn't cross over, right? It doesn't have a continuous place at x equals 5. There's a weird sort of jump between where they go. So my function could possibly go from positive to negative here at x equals 5. So now I'm going to approach this just like I did the quadratic inequality. It's just that I got my zeros from the numerator being 0 and the denominator being 0. This is a technique that we are going to use really a lot throughout the semester. So that's a really good thing to sort of get a good hold on it. So I'm going to have 0 way down here. Let's see, 5 I'll put here, and 8 I'll put here. Okay? So now this is equal to. Okay, so that means, now I have to be really careful. Now my 0 will be a solution. Okay, so that means that 8 could be a 0 because this one is a 0. This is a domain, this is basically an undefined space. My undefined spaces, I never include them because they're not part of my domain. So I have an open circle here. Okay, so that'll help me when I figure out the rest. So now I'm looking again at my sign. This is less than or equal to 0. What I'm going to do is just like a quadratic inequality, I'm going to test a point in each one of these intervals. And I'm looking for, because this is less than or equal to 0, I'm looking for the negative ones. So I'm going to, maybe it'll help us a little bit. I'm just going to write up here the different, so these 2 points break my intervals into different pieces. Right, I'm going to use a little interval notation here, but this goes from negative infinity up to 5, this part, right? Then we have this part down here, which is 5 to 8. The 8 is included, so I can write it like this. And then the last interval is 8 to positive infinity, and it's also included. So if I wanted to write these as an inequality, this would be x is less than 5. This is x is between and equal to 8, less than 5 or greater than 5, and then x is greater than or equal to 8. These, in some combinations, are going to be part of my solution. So I'm just kind of doing that in advance. All right, so now I want to pick a point out here. 0 is out here, so let's look at when I plug in 0 over here. I'm going to get, basically these 2 pieces are going to be gone, and I'm going to have positive 8 over negative 5, which is negative. So I have a negative solution in there. So that is part of my solution, right? So then this, either one of these, depending on which I want, that's part of my solution. All right, so now I want to choose a number between 5 and 8. So how about if we choose 7? So if I plug in 7 here, I'm going to get negative 7 plus 8, which is positive. And if I plug in 7 here, I get 7 minus 2, which is positive. So positive divided by positive is still positive, right? So it's positive in here. I know I'm looking for something negative. That's not going to be part of my solution. So now I'm going to check out here. So let me choose a number like 10. So 10 would be negative 10 plus 8, which is negative 2. And 10 minus 5 will give me positive 5. So I have a negative on top divided by a positive on the bottom. So that's going to give me a negative value overall. So that means that this or this is part of my solution. So I could write this 2 different ways. Either I can write it as x is less than 5, or x is greater than or equal to 8, or in interval notation I could say negative infinity to 5, union 8 to positive infinity. So this means I've got an open circle. This means I have the closed circle. So here's my solution. Now be really cautious. I know that you kind of get used to when you're working with a quadratic inequality the fact that you get this sort of opposite negative, positive, negative, positive, negative, positive sort of solution, and that is not always the case. And in fact, most of the time it's not the case when we're dealing with rational functions. So there's no real pattern to it when it comes to that. All right, so let's do another example. We're going to go about it the same way. This time our rational inequality is made from 2 rational terms. Okay, so the first thing that I want to do is make 0 on one side. So let's do that first. I have x plus 2 over x plus 3, and now this will be minus over here. X minus 1 over x minus 2 is greater than 0. All right, my least common denominator here will be, right, it just needs both of these terms. So I need x plus 3 and x minus 2 as my least common denominator. All right, so I'm going to make my common denominators here. I start out with this. Okay, so this is what I want my denominator to be. This is what I have. So I currently have the x plus 3. I need the x minus 2. So I'm going to multiply the top and the bottom of this fraction by x minus 2. And remember that I'm going to use parentheses because I'm going to need to FOIL those, or multiply them all out. All right, so then I have minus. Here's my original. This time, this is my least common denominator. What part do I have? I have this part. I still need this part. So I'm going to multiply this by x plus 3 over x plus 3. Right? The order doesn't matter when it comes to multiplication, right? X plus 3 times x minus 2 is the same thing as x minus 2 times x plus 3. So now I have my sign here is greater than 0. All right, so let's open up all of our parentheses on the tops of our fractions. So I have x plus 3 down here, x minus 2. My first fraction will be, this is going to end up multiplying to give me x squared minus 4, right? Because my 2's will cancel because this is the difference of two squares. And then I have minus, here's my same denominator down here. And I multiply these together and I get x squared plus 2x minus 3 is greater than 0. All right, so now I need one fraction. Thank goodness I don't have to write this denominator another time. All right, so now I have one fraction. I have x squared minus 4, and then when this minus, it goes on all the terms. X squared plus 2x minus 3 is greater than 0. All right, so let's distribute the minus. I get minus x squared minus 2x plus 3 on top. Denominator, x plus 3 times x minus 2 is greater than 0. Oh, how nice. My x squareds cancel, right? They just knock each other out. And I'm left with negative 2x and then minus 1 on top. All right, so now this is going to break me into a couple of things, right? So now I need to know where either my denominator is 0 or where my numerator is 0. Okay, so I'm going to set my 0 is minus 2x minus 1 is equal to 0. And so I'm going to have negative 2x is 1. X will be negative 1/2. Okay, oops, there we go. And then for my undefined places, I get x equals negative 3 and x equals 2 when I set these two things equal to 0. I'm not writing it out, but I think that's pretty straightforward. All right, so now I have 3 numbers on my number line. So let's start up with a new page here. All right, so let's put all of our numbers on our number line here. So here's my 0, so here's negative 1/2. I have positive 2 maybe here, and then negative 3 back here. All right, now this one was my original, let's see, or my nice cleaned up version is here. Like I want to use that one when I'm testing things out. I hope that I did all my algebra right. So I'm going to have, I know I always have open circles where my denominator is 0. And because then there's no equal sign, then this last one will also be an open circle. So none of the solutions that I currently found will be part of my solution, but it does break my number line into different parts. Okay, so if I look at this part, we'll just practice rewriting these. So in this first interval here goes from, if I want to use interval notation, negative infinity to negative 3, open parentheses, or I could write it as x is less than negative 3, either one of those. So when I test a point in there, let's say I'm going to use, I don't know, let's use x equals negative 10. It's a nice big number. When I plug in x equals negative 10, I'm putting it up here. So I'm going to get negative 10 times negative 2, so that's actually going to be 20 minus 1, so I'm going to get a positive value on top. I'm just writing the sign, I don't care about the number. And then negative 10 on the bottom, right, that'll be negative, so I get a negative times a negative on the bottom. Well, negative times a negative gives me a positive, so I get positive divided by positive, so it's positive overall. So looking here at my inequality, I did want greater than 0, so this will be part of my solution. All right, so let's look at the next interval. So the next interval goes from, they're both open circles, so we write that in interval notation as negative 3 to negative 1/2. Or I could say that x is between negative 1/2 and negative 3, like this. All right, so let's use a nice integer here. So let's try an x equals negative 1. So if I plug in negative 1, I get negative 2 times negative 1, which gives me positive 2 minus 1, so I get a positive value on the top. Okay, and then I'm going to plug in negative 1 in the bottom. That'll be positive. That'll be negative. So I'm going to end up with a positive number divided by a negative number, because a positive divided or times a negative is negative, and so I'm going to get a negative value overall. So that is not going to be part of my solution because I'm looking for greater than 0. All right, so let's see, next number that I want to try out. Ooh, that's on. So I need negative something between negative a half and 2 in interval notation, or I could write it as negative a half is less than x is less than 2, like this. So let's choose, how about positive 1? Okay, so I'm going to come back here to my original function, plug in 1. Now this time it's positive 1, so this will be negative 2 minus 1, which is negative on top. Alright, so then I put 1 down here, and I'm going to get 4, which is positive. I put 1 down here, and I'm going to get a negative. So I have a negative divided by positive times a negative is negative. So I end up with negative divided by negative, which gives me positive. Right? Whenever I divide two negative numbers, multiply two negative numbers together, I always get positive numbers in return. So this is positive, and since I am in fact looking for greater than, like this will be part of my solution. So now my last thing is to check something bigger than 2. I'll just choose 5 for ease. Alright, so our original, let's see, function was this. Okay, so I'm going to plug in x equals 5 here, and I'm going to get, let's see, 5 times negative 2 is going to give me negative 10 times and minus 1 more, that's negative on top. And then 5 down here, this will be positive, and this will be positive. So positive times a positive is positive, so I have a negative divided by positive, which gives me negative overall. Okay, which means I'm going to put my minus sign up here, and that is, again, since I was looking for greater than 0, right, that was my original sign, this is also not part of my, and that would have been written in interval notation like this, or x is greater than 2. So my two solutions, I can write, or I have my solutions in two parts, so in interval notation I would write this union this, or as an inequality I would write x is less than negative 3, or it's between negative a half and x and 2. There we go, like this. Okay, either one of these is perfectly acceptable. This is interval, this is an inequality. So an application, right, of this type of inequality are domain restrictions. So what if I had f of x equals 1 over x minus 1? So it's the square root of 1 over x minus 1. So what would I need to do? Oh, well, first of all, I know that this needs to be positive. So the first thing that I do is set this thing greater than or equal to 0. And boom, I have an application, right, of my rational inequalities. So this is really nice because I don't really have to do much work here because I have a common denominator. I just have the one thing, and so I know that at x equals 1, I'm going to get a 0. I put that number on my number line here, right? And it will be open because it's in the denominator. It says equal to 0, but this doesn't give me 0 when I plug it in. It gives me 1 over 0. So it's not defined for that. And so if I test a number on this side, let's say I put in 3, then I get 1 over 3 minus 1, which is positive. And if I plug in a value on this side, let's say x equals negative 5, then I get 1 over negative 6, which is negative. So this is the negative part. So that means my domain restriction for this particular part is this piece of my number line, from 1 to infinity, where x is greater than 1. So that's an application that we can use.